Okay, it's time to solve some equations with variables on both sides. As you can see, we've got one here where we've got 8b here and we've got 7b here. The only way we can ever solve an equation like this is if we can somehow get all the variables together on one side of the equal sign and then just constant numbers on the other side. Once we get that done, it's usually either a one or a two-step equation that we have to solve, and by now we're really good at doing that. So let's get started. Before we begin, keep in mind what we're saying here is that an equation is like a perfectly balanced scale. So whatever is on this side weighs exactly the same as this side to keep things balanced. And this is why whatever we do in solving an equation, we have to make sure we do once on each side to keep things balanced like a scale. So first decision we have to make here is which side should I put the variables on? Should I put them here on the left where 8b is, or should I put the variables only on the right-hand side? A lot of teachers always tell students to put it on the left. I tell students it's really up to you. It's your decision. One thing I always suggest is try to do it in such a way that you can avoid having negative numbers, because it's easier to make mistakes with negative numbers than with positive numbers. So in this case, what I want to do is I'm looking here and I see that 8b here, 7b here. I'm going to choose to put the variables over here on the left side because I've got more of them here. And so if I take 7 away from here to get rid of it, then because I've got the scale situation, I have to take 7 away from here as well. I'm still going to have a positive number of b's left. And that's usually the basis that I use to make the decision of which side to work with. All right, so let's take 7b here, and we'll subtract 7b here. Still an equation, and still true. 8 bananas take away 7 bananas is just 1 banana. And the minus 9 just comes down. This cancels out, and what I'm left with is a negative 5. I'm going to make this pen a little bigger. Okay, so this is just a one-step equation. The variable b is having a 9 subtracted from it, and that equals negative 5. So the way to undo subtraction is to add. So I'll just add 9 here and here. Negative 9 plus 9 is 0, so this is b, and negative 5 plus 9 equals 4. Now, as usual, we should really do the check step. Remember, when you're solving equations, you should always be able to tell if you did it right or not, because you can plug your solution back in. Is it true that 8 times 4 minus 9 is equal to 7 times 4, minus 5? Well, this is 32 minus 9. This is 28 minus 5. 32 minus 9 is 23. 28 minus 5 is also 23, so I know it worked. Here's another one. In this case, I've got negative 3h here, and I've got negative 5h over here. So as before, I've already got just plain numbers on this side. So maybe a good short step to do would be to get rid of this negative 3h, and then I'd only have plain numbers here, and I'd only have h's over here because there's no constant numbers on this side. So how do I get rid of a negative 3h? Well, I add a positive 3h. And just as before, we've got our balanced scale. If I'm going to add 3 pounds to one side, I'm going to have to add 3 pounds to the other. So we're going to add it once on each side. This cancels out, and I just have the number 10 left. Negative 5 plus positive 3 is negative 2. We can use a calculator, obviously, for this part if you have any difficulty remembering your integer facts. Of course, we'd like you to know them, but we don't want it to stop you from developing the algebraic equation solving skill. So now h is being multiplied, so we're going to divide by negative 2. This is a negative 2, so that's being multiplied, so I'm just going to do the opposite in this case, divide by the exact same number, negative 2. So these cancel out, and I just get 1 times h, which is h. 10 divided by negative 2 is negative 5. Real quick check step. Negative 3 times negative 5 plus 10, is that the same thing as negative 5 times negative 5? Negative 3 times negative 5 is 15. Add that to 10. Negative 5 times negative 5 is 25. So this one also checks out just fine. I got these directly from my Excel, so you may see these exact equations if you're lucky. Okay. This one's a little different because I've got a number and a variable, and a number and a variable. So I've really got to decide which side to put the variables on and the numbers. This is a smaller number than this, or actually it's a greater number because they're negative. So what I might want to do is I could add 7y to both sides, and that would give me a negative 3y over here. But again, I'd like to avoid working with negatives just because it's so easy to make simple mistakes when you do that. So I'm going to do this instead. I'm going to add 10y to both sides. That way I'll get rid of the variables on the right-hand side. These cancel out. I'm left with negative 10. And then I'll have a positive number of y's here because negative 7 plus positive 10 is 3. So over on this side I have that 8 still plus 3y. So I've done a good job here. I've gotten my variables on one side, but now I have what amounts to basically a two-step equation. So I could either move the 8 over and then solve it as a one-step, or I could do the do-undo table. Let's just review that real fast. Since I've got a two-step equation, I could say that my equation started life by saying the variable y is multiplied by 3, 8 gets added, and I end up with negative 10. So if I want to undo that, we're going to do the opposite of each step. So instead of adding 8, we'll subtract 8. Instead of multiplying by 3, we'll divide by 3. And then if I do the math here, negative 10 minus 8 is 18. Negative 18, I should say. And then negative 18 divided by 3 is negative 6. So if we do the check step over on the side here, hope I have enough room. Is it true that 8 minus 7 times negative 6 is the same as negative 10 times negative 6 minus 10? Ooh, a little short under there. All right, so 8 plus 42, because negative 7 times negative 6 is 42. That's 50. And this is negative 60. Sorry, positive 60, because that's negative times negative. Positive 60 minus 10, well, that also equals 50. All right, very good. Last one. This one looks really strange. What some students would think as soon as they look at this is that these q's would cancel each other out. It kind of looks like that at first glance, but you have to think carefully and realize what I'm really going to do is to get rid of, if I want to put the q's over here on the left, let's say, I'm going to have to add a positive q to cancel out this negative q. And when I do that, they're not going to cancel out on the left. There's just going to be two of them now. So negative 3 plus q, which is 2q. My q's are awful, I know. And then that equals 9. So now we're back to the do-undo situation. I've got to look at what happened to the variable, and I'm just going to undo it in reverse order. So we started with q, and then it was multiplied times 2, and then they added a negative 3 on top of that to get an answer of 9. So now, let's go backwards. Start at 9. Instead of adding a negative 3, I'm going to subtract a negative 3. Instead of multiplying times 2, I am going to divide by 2. If I do my math here, 9 minus a negative 3 is really the same as 9 plus 3, so that's 12. 12 divided by 2 equals 6. I'm going to write a really small check step here for you. Negative 3 plus 6. Is that the same as negative, the opposite of q, in this case the opposite of 6, plus 9, plus 9. Negative 3 plus 6 is 3. Negative 6 plus 9 is also 3. Thank you very much. Have fun.